Hello students, in today's video I am going to discuss some properties of inverse trigonometric functions, and this is the part 1 in this series. So students, as you can see here, there are three properties mentioned here, like A part, B part and C part. In A part we have to prove sine inverse of 1 by x is cosecant inverse x. B part is cos inverse 1 by x is secant inverse x, and C part is tan inverse 1 by x is cot inverse x. In order to prove the first property, I mean to say this property, my consideration is cosecant inverse x is y, which will be provided as x equal to cosecant of y. And we know cosecant of y is 1 upon sine of y. Ultimately sine of y is 1 upon x, or we can write here y is sine inverse of 1 by x. And what is the value of y, which can be taken here from? So cosecant inverse x is sine inverse 1 by x. Ultimately sine inverse of 1 by x is cosecant inverse of x. So that is the proof of first property. Thereafter, this is the second property which we have to prove. For this purpose I have considered this term secant inverse x equal to y, that is x equal to secant of y, and we know secant of y is 1 upon cos y, so that is what I have written, or cos of y is 1 upon x. Ultimately y is cos inverse 1 by x, and how to get the value of y here from the consideration secant inverse x is equal to cos inverse 1 by x. Ultimately cos inverse 1 by x is secant inverse of x. So in such a way second property is also proved. Thereafter I am talking about third property. Tan inverse 1 by x is cot inverse x. For this purpose I have taken this RHS, right hand side equal to y. Cot inverse x is y, or x is cot of y. Since we know cot of y is 1 upon tan y, or tan y is 1 upon x, or y is tan inverse 1 by x, and we know this value of y is cot inverse x, that is what I have written here. So cot inverse x is tan inverse of 1 by x. Ultimately we can say tan inverse 1 by x is cot inverse of x. So in such a way students, all these three properties are discussed. Thereafter three more properties I have proved, which I am going to discuss with you. So first property here is sine inverse of minus x is minus sine inverse x for the values of x in the interval minus 1 to 1. Second property is tan inverse of minus x is minus tan inverse of x, where x is from the real line. And C property is here cosecant inverse of minus x is minus of cosecant inverse of x, where mod of x is greater or equal to 1. Now I am going to prove the first property, that is sine inverse of minus x is minus sine inverse of x. For this purpose I have taken this left hand side equal to y. Ultimately minus x is sine y, or x is minus sine y. As we know, sine of minus theta is equal to minus sine theta. So that particular formula I have utilized here. Minus of sine y is sine of minus y, or we may write it sine inverse of x is minus y. And by putting the value of y from the consideration here, it will be like sine inverse x is minus sine inverse of minus x, or we can write it sine inverse of minus x is minus sine inverse of x. So that is the proof of our first property. Thereafter the second property here is to be proved is like tan inverse of minus x is minus tan inverse of x. For this particular property proof, I have taken this tan inverse of minus x is y, or minus x is tan y, or x is minus of tan y. And we know tan minus theta is minus tan theta, so minus tan y is tan minus y. So ultimately it can be written like tan inverse of x is minus y, or this value of y can be taken here from tan inverse of minus x. Ultimately tan inverse of minus x is minus tan inverse of x. Thereafter, the last property in this video is cosecant inverse of minus x is minus cosecant inverse of x. So for that purpose, I have considered cosecant inverse of minus x is y, or minus x is cosecant of y, or x is minus cosecant of y. Ultimately, I can again utilize the formula cosecant of minus theta is minus of cosecant of theta. So this cosecant of this minus cosecant of y is equal to cosecant of minus y. So from this step I can write cosecant inverse of x is minus y, and this y value I can take in from the I can take from the consideration. So that is minus cosecant inverse of minus x. Ultimately I have proved it. Cosecant inverse of minus x is minus of cosecant inverse of x. Thank you so much students for watching this video.